on, here we are, the last question of the paper. Fantastic, what an emotional roller coaster. Oh, it's quite tiring, isn't it? When you go through it all the way, especially if you've been timing yourself or something. It's yeah, there's a lot to draw on. It's quite a long time to sit and just be thinking, especially if you are trying to really simulate an exam and you're trying to get up every mark and not make a silly mistake or anything. You're checking what you've been doing, so it's quite intense, yeah. So yeah, last question must feel good. And again, when you go through these papers, feel free, do it in any order you like. You know, maybe you want to soak up, you know, do the straight lines and the polynomials and the quadratics, you know, and then you finish off on maybe something like the circle or the graph questions where there's a wee bit of, you know, critical thinking. But yeah, before I even read the question, I'm going to write CRE because it's a circle question. In the same way I write down PGE for straight lines, I'm going to write down CRE. Then I'm going to read my question. So circle 1 is a circle with this equation. So I'll just write the equation down there. So sometimes you're writing the equation from the centre and the radius, but I'm just going to write my equation down. Because part of my nails, it keeps everything quite nice and neat together when I do this, right? So this is for circle 1, my CRE. Okay, so state the centre and the radius. Well, the radius, this is in the form r squared, so the radius is just 10. I'll write it properly. The radius is going to be root of 100. My pen catches up to me. So the radius is just 10. And the centre is just changing the signs of what's inside the bracket. So it's going to be 7, negative 5. So let's see, 7, negative 5, boom. Right. So usually you're doing this and this to get to that, but we're working back the way. So that's us got our marks for question 1. Part 2. It's saying hence or otherwise show that this point lies outside the circle. Okay, so I've got my equation for the circle. And does that point lie on the circle or out the circle? Now, when you think about it, this is really just, you know, it's two sides to an equation, and that is r squared. So that's like that's the length squared. So you can think on that as like a you know, value of length. Okay. Now this number here, what if that comes out as something smaller than this? It would make sense that it's inside the circle, wouldn't it? You know, if you've got the radius there is 10, so 10 squared is 100. If this number here comes out smaller than 100, it would make sense at that point has to be, you know, somewhere like there or there or there, because that number, that distance from the centre to there squared isn't quite 100 squared. In the same way, pen's really slow, in the same way that if this side is bigger than 100, it's going to be outside. So all we're going to do is let my pen catch up to life. Okay, so all we're going to do is substitute in our value. We're going to substitute our value in. We're going to say that I've got, what is it, negative 2, so it's a negative 2. Oh, well, the computer started to die on me. It is also as tired as maybe you are. Try again. Okay, let's try that again. So I'm putting in negative 2, and I'm putting in 7, and everything else is just going to stay the same. And we're going to see what that equals. So let's have a, well, you know, I'll go into the next line for that one. So what does that equal? Well, that's the same as negative 9 squared plus 12 squared. So that's the same as 81 plus 144. So that is equal to 225. So if that's equal to 225, I would then be saying that 225 is greater than 100, therefore is outside the circle. I think, to be fair, this line didn't really, well, maybe, I think what I didn't need was this bit equals 100. Yeah, I would have just done that, actually. If you want to try and visualize this as well, you know, you could actually have written your equation out. It was just to try and get you started. I was just trying to think of something else, but I think another way of thinking on this is it's a bit like Pythagoras, really, isn't it? If you've got your triangle, like this, so you've got your x and your y and your r. So you're saying that x squared plus y squared is r squared. So if you do the left hand side here, if you work out that this value is less than r squared, then your triangle has to be a wee bit smaller, doesn't it? You'll be doing something like that. So it's inside the circle. But if your triangle is bigger, if you get your x squared and your y squared come out as more than r squared, then you're kind of beyond there, aren't you? So it's you just I'm just trying to give you something else to think about. The point is you're substituting into the equation. If the equation holds true, you're on the circle. If this side is less than your r, then you're inside. But we were bigger, so we're outside. So there's your 2 marks for that. And the next bit, C2 is a circle with a centre P, with that centre and radius r. Determine the values of r for which these have 1 point of intersection. And this is the kind of question that probably I would definitely leave till the end because they're a wee bit trickier than some of the other questions we were thinking involved. So let's do a little sketch for this one. If you're not doing, once you do CRE, you're definitely wanting to do a sketch for the circle. Okay, so I've got my main circle. I've already had that. That's the centre, that's C1. So the centre for this one is 7, -5. And the radius for this, we said was 10. And we said that point P lies outside the circle somewhere. And it's at -2, So we'll call that C1. And I'll say that this is, we'll just scroll over a little bit. I'll do it over here. So that's -2, 7. I mean, that makes no sense the way I've drawn it, but never mind. And it has got a radius, which we don't know, but it's saying what is the value of that radius for which they've got exactly 1 point of intersection. So they've got 1 point of intersection. It's going to do something like terrible drawing. It's going to do something like that. I don't know. I don't know if this circle is bigger or not. I've drawn it bigger, but I don't know if it is. So if it's got 1 point of intersection, we are saying that the 2 radii must add to this distance between these 2 points is the point. Okay. So let's draw a little right angle triangle. And we've got our 2 centres. I've got -2, 7, and I've got 7, -5. So what's the x coordinate then? Well, that x coordinate is 9. It's the difference in the x values. And the y coordinate, the y distance in the y's is 12. So this distance here is going to be 12 squared plus 9 squared square root. Okay, so I'll call that x. So x squared, 9 squared plus 12 squared, so 81 plus 144. So we've sort of kind of worked that out already, really, haven't we? But so x squared is 225. So x is going to be 15. So we've kind of done that over here. So maybe someone smarter than me might have worked that out. But anyway, so we've got 15 as our distance. So if that whole distance is 15, right, I'm not really drawing it very well, but the whole distance is 15. It means this radius is going to have to be 5, isn't it? So I know the radius is 5, and I know that the centre is going to be this with its sign changed. So I'm going to say it's going to be x plus 2 squared plus y take away 7 squared is equal to the radius 5 squared, which is 25. And we'll just check the marking scheme. Yeah, that's fine. So you're going to mark for the 5 and a mark for the 25, apparently. I don't see any more marks, which is a bit weird. Did the question ask for the equation? Oh no, it just asked for the radius. Sorry, yeah, it asked for the value, the radius. So the radius would be equal to 5. Sorry, so there you go. So just saying r is equal to 5 would be fine. So yeah, I hope that was helpful.